I usually wrap up my HeyGears reviews with "this printer isn't for everyone," and that's always been true. HeyGears has carved out a very specific corner of the 3D printing world. Their machines are locked down, the slicer is proprietary with zero access to print settings, and they only officially work with their own branded resins. That's made HeyGears something of a pariah in the broader maker community, but for users who want a printer that just works, no calibration, no resin tuning, no dialing in exposure times, just load, click, print, and get perfect results every time, HeyGears has delivered something uniquely powerful for that kind of workflow. They started with the Reflex, followed it up with the more hobbyist-friendly Reflex RS, and now we've got the Reflex 2. But I'll be honest, after a solid month of using the Reflex 2, my first instinct was to say, this might be one of the worst printers I've ever reviewed. From frustrating software to some truly questionable design decisions, it felt like a step backwards in almost every way. But then something strange happened. Despite all the pain points, I started to see a pattern emerge, a very specific use case for a very specific kind of user, where this printer doesn't just make sense, it might actually be the best tool on the market. And here's the thing, the person I think this was built for, that's not the person HeyGears says it was made for. So if you want to see how something can be really bad and maybe brilliant at the same time, stick around. While this review ended up going in a completely different direction than I expected, we're still kicking things off the same way I always do, with the setup and specs along with a few frustrations. My machine went through a full custom inspections on its way to me, so I can't speak to the standard unboxing, but it arrived intact and functional. The machine has a 17-inch square footprint and stands just under 2 feet tall, with a lid that adds about 3 inches when open. The stainless steel build plate offers a 230 by 140 millimeter XY area with a 230 millimeter Z height for a total build volume of 7,612 cubic centimeters. It locks in place with a large tension lever and features perforations that improve early layer flow dynamics but prevent direct on-plate prints, a limitation for certain workflows, as I'll show later. The Z-axis uses dual linear rails and a 230 millimeter stroke C5 grade ball screw, and that's arguably overkill. Ball screws are great for CNCs, but not needed here. MSLA Z motion is short and slow. A trapezoidal screw would have been quieter, cheaper, and just as precise, while avoiding added heat and complexity from torque holding motors. Moving down to the display, this is where most of the R&D effort went in compared to the original Reflex. The Reflex 2 uses a 10.7-inch Amber Screen Pro paired with what HeyGears calls the 161 OptiZone light engine. Let's start with the screen. If you're chasing the almighty K number, you might be disappointed. This is a 6K display with a diagonal resolution of 6,795 pixels, 635 pixels per inch, and a pixel size of 40 microns. But as I always say, K is just the marketing number. It doesn't tell the whole story. In the Reflex 2, the display and light engine work together to produce some of the most accurate prints I've ever seen. So how does it work? The light engine starts with a 161 LED array where each LED is independently addressable. That means only the LEDs directly under the part being printed are illuminated, and even then, each LED's intensity can be fine-tuned. That level of control allows for precise exposure dose tailored to different parts of the model. Thin walls, thick walls, outer surfaces, support structures, even support contact points all get exactly the UV energy they need. The light is collimated through a honeycomb baffle, then focused through a lens grid array before hitting the screen. The display itself includes an amber polarizing layer that acts as a final filter, ensuring only UV light at the correct frequency, 385 nanometers, passes through. Quick physics lesson: when UV light scatters, it loses energies, dropping in frequency. That polarized amber layer blocks scattered photons, which boosts contrast and exposure accuracy, and the advantages here are huge. Because the printer only illuminates selected areas of the screen with UV light, it produces far less heat compared to full screen masking approaches. That reduction in thermal stress significantly extends screen life. HeyGears claims the Reflex 2 offers 12.5 times the lifespan of the original Reflex with a service life of over 6,000 hours. I've only racked up a few hundred hours so far, so I can't independently confirm that, but the physics absolutely support it. As for the 385 nanometer wavelength, compared to the standard 405 UV light used in most MSLA printers, the 385 nanometer photons carry higher energy. This allows for faster and more complete resin curing, improved dimensional accuracy from less bleed and diffusion, better performance with advanced engineering resins that require tighter energy control. It's a noticeable step up for certain print applications, particularly when precision and dimensional accuracy matter. And the display is modular and replaceable. In fact, it's even easier to swap out than the Reflex RS. Just 6 screws and it pops right off. HeyGears has even hinted at future higher resolution upgrades for this system, which could make this printer a long-term investment, assuming everything else holds up, because there's no guarantee there. Above the screen, a standard metal vat screws into place. It features clear PFA release film and holds up to 900 milliliters of resin. The vat integrates with HeyGears' gravity-fed resin system using the spring-loaded bottle caps found on most of their resin bottles. Instead of a top-load system, bottles are side-loaded into the printer. That might sound like a welcome change until you try it. You need clearance on the right side of the machine, not just to install the bottle, but to physically lean in and check to see if the spring cap engaged correctly and it's not leaking all over the place. In my case, one spring cap failed and resin kept pouring out as I tried to remove the bottle. I had to scramble to grab a container to avoid flooding my entire workspace. More frustrating is that the Reflex 2 ships with a secondary, wider opening spring cap for use with their resins for the Reflex 2, which you're expected to swap in manually. But even with that in place, flow rate on the PAU20 was painfully slow. So slow that in one test, the printer started printing before the resin had even reached the bottom half of the vat. I'll come back to this problem in more detail later. Now, the standard vat is fine for general purpose HeyGears resins, PAS10, PAP10, PAF10, and the transparent resin. But if you want to use the more advanced engineering resins like PAU20, the polycarbonate like PAE10, PA20, the elastomers, and the PAH270, the heat-resistant casting resin, you'll need the optional pulsing release vat in the new pulsing release module 2.0. Like previous versions, the PRM uses air pressure to flex the release film. This reduces peel forces, improves print speed, and minimizes support touch point size and density, especially useful with delicate or high precision parts. But as of filming, only select resins have profiles for use with the PRM2 in the Reflex 2. Several materials that did support the PRM on the Reflex RS are currently unsupported here. That could change with updates, but as always, I don't review promises. Another promise I can't confirm is that the PRM1 may work one day with the Reflex 2, but for now, only the PRM2 is compatible. One trade-off of the new PRM vat is that it loses the built-in heater. Instead, HeyGears moved the heater functionality into an optional heated scraper arm. This arm not only warms the resin, especially useful for resins like PA810 with higher working temps, it also keeps the resin mixed during printing. That's crucial for the filled resins like PAH270, where additives need to stay evenly distributed. But here's the problem. The arm only includes a basic end stop sensor. If it hits a failed print in the vat, it'll just shove it around like a hockey puck, sloshing resin everywhere. No collision detection, no feedback loop, just chaos. For a first-hand look at that, check out Tony, aka Gree3D. He documented the whole unfortunate mess in his video. And speaking of sloshing, the resin comes very close to the top edge of the vat. Accidentally overfill it, and you're flirting with disaster. HeyGears solution? They uploaded a printable splash guard STL instead of just designing a properly sized vat in the first place. With the heating now in the arm, they easily could have made a safer, low-cost plastic vat like what Formlabs uses on the Form 4. Again, to see the knee-jerk solution in action, go check out Gree3D's review. And this printer is definitely not designed for overflows, with a big open slot right on the top for the wiper arm and a trench under the display. Again, bad design choices. Now, as for sensors, the Reflex 2 still includes a display force sensor capable of detecting failures or debris down to 150 microns. That's useful for analyzing force curves, diagnosing issues, and improving reliability. There's also a resin weight sensor to monitor bottle usage, but I drained a bottle during testing and the printer never notified me, so take that with a grain of resin dust. What's missing is equally important. No camera for print monitoring, AI-assisted failure detection, or even basic remote supervision. No resin level sensor in the vat, no overflow detection, no scraper collision detection. Again, this led to a serious problem in my testing. That PAU20 resin flowed so slowly, the print job started with half the vat still dry. I had to cancel it manually. For a printer that positions itself as just works, that's not a miss, it's a fundamental failure and basic fail-safes. To wrap up the specs and features of the Reflex 2, the power input and power switch are located on the rear of the machine. There's a USB Type-A port on the right side for sneaker netting files to the printer, and while I'd normally prefer that USB port be up front, its location doesn't really make a difference here, as space is already reserved for the side-loading resin bottle. The Reflex 2 copies your slice files to the 20 gigabytes of onboard memory before printing, which is a great fail-safe to avoid jobs being interrupted by flash drive removal or corruption. There's also a micro SD card slot that's supposed to supplement the internal storage, but as far as I can tell, it doesn't actually do anything yet. On the network side, the Reflex 2 includes an Ethernet port, which again, I'd prefer to see on the back next to the power input. On the front of the machine is a very responsive touchscreen used to access the HeyGears operating system and UI. Once the machine was unpacked and powered up, the setup wizard walked me through the basics: language, time zone, network setup, and that's where I hit my first real snag. The Reflex 2 could connect to my Wi-Fi 6 router, but then it couldn't connect to the cloud service. I had to fall back to an older Wi-Fi 5 router to get it online, something to watch for depending on your network. After the network setup, the Reflex 2 ran its light source test and all display zones passed without issue. I installed the resin tank and build plate, shout out again to that big locking lever, which feels rock solid. And I secured the scraper arm, which features spring-loaded heater contact points and a captive thumb bolt to lock it in place. Last step before printing is platform leveling test. While these machines are leveled at the factory, my unit failed that check. No surprise, considering its less than gentle journey from China. Luckily, manual leveling is simple. Just pop off 2 rubber caps and use the included Torx driver to turn the leveling screws until the indicators turn green.
There's also a built-in auto leveling system. The entire gantry seems to have a lot of movement or racking. However, that's part of the floating plate leveling system. The Reflex's 2 plate gantry uses 4 sensors to detect and compensate for Z-parallelism deviations up to 250 microns. After ensuring the first few layers are printed flat, a mechanical mechanism locks the gantry in place parallel to the display.
Finally, I installed a resin bottle, but honestly, after nearly flooding my workspace once, I ditched the auto feed entirely and just pre-filled the vat manually. That may defeat the point of the gravity feed system, but it gives me more control and fewer surprises. At this point, setup should be complete and I should be ready to send a file and start printing. However, the one thing the initial setup missed is leveling the actual printer. Especially with that wiper sloshing the resin around, you want to ensure the printer is perfectly level. There's a very nice function for this in the settings that uses the internal gyroscope and the adjustable feet. Just like the plate leveling, you spin the feet in the indicated direction until it turns green and the bubble is centered in the circle. I love the feature, not sure why it was skipped in the setup. The final spec is, of course, the price. And brace yourself, the MSRP of the base configuration of the Reflex 2 is $1,799 US. Of course, if you want to use the advanced resin, you'll need the PRM2 and VAT plus the heated scraper, bringing the total cost up to $2,568 US. HeyGears is running an early bird sale and even gave me a discount code to share. There'll be links in the description, but I suggest you finish the review before you rush off and buy. Well, that's the printer and some of its flaws, but from this point on, I really want to shift focus to what matters most, the actual print quality. But before we dive into results, we need to take a quick look at the software side. HeyGears printer uses a slicer called Blueprint Studio, or BPS, and like everything else in HeyGears ecosystem, it's proprietary. You can only use BPS, and I'm not doing a full walkthrough here. If you want that, check out my Reflex RS review, but I'll say this. BPS is about as streamlined as it gets. You start by selecting a printer, choosing the type of project, whether or not you're using the PRM, then you pick the resin, set your layer height, and you're in. From there, drag your models onto the build space, repair them if needed, orient them, auto support, slice, and send it off to the printer. That's the workflow. But what's noticeably different about BPS is what it doesn't give you. You don't get access to any of the typical slicer settings. There's no bottom exposure time, no layer exposure time, and honestly, those are the only 2 settings most MSLA users even touch. But It goes further than that. There's no control over PWM, no light intensity adjustments, no lift speed, no delay settings, no scale compensation. All of those things are preset by the slicer based on the resin you choose, and they're adjusted dynamically by the printer during the print itself. And that's actually kind of brilliant.
Let's say you don't have the heated scraper and start a print in a cold room. Exposure times will automatically run longer to ensure proper cooling as the resin warms up, either from the ambient environment or the exothermic reaction of the curing process. The printer detects the change and shortens the exposure times to compensate. Even with the heater, the resin temperature can still exceed the optimal range in warmer rooms or during long prints, and the system continually adjusts in real time to maintain ideal curing conditions. That kind of adaptive control is a big part of what makes HeyGears printers some of the most reliable consumer MSLA printers out there.
But reliability comes at a cost of control. If you're someone who loves dialing in every tiny setting or pushing print speed boundaries, this will feel restrictive. And again, before jumping into results, I think it's also important to clarify who HeyGears actually built this printer for. According to their own marketing brief, the Reflex 2 is aimed at creators in small to medium-sized studios looking for enhanced reliability and streamlined workflows. It's positioned as an all-in-one solution for things like model creation, functional verification, small batch and use parts, and casting workflows. In other words, this isn't a casual printer for someone occasionally cranking out a tabletop mini for game night. And honestly, the price already tells you that. HeyGears built this for professionals, for engineers, product designers, and creative teams working in iterative design cycles. This is the same space where machines like the Formlabs Form 4 live. And naturally, that's where I focused most of my attention for this review. Now, this is YouTube, so yeah, I kick things off by printing some miniatures and a large multi-piece character model just to see what kind of performance I'd get out of the box. But the bulk of my time was spent testing the Reflex 2 the way HeyGears says it's meant to be used. To kick off the test prints, I filled the vat with HeyGears PAP 10 production resin and loaded up a multi-part Superman model. I oriented the parts, hit auto support, sliced the file, and sent it to the printer. Now, one thing to note, you still have to manually start the printer at the machine. There's no remote start, which honestly is probably for the best. With no onboard camera, you'd be printing blind otherwise. Once the job was queued, the printer ran through its pre-checks and began heating the resin. This was a little nerve-wracking for the first time, watching it warm up and top off the vat automatically, but I never had an overflow. Still, it gets real close, so proper leveling is critical. Once everything was up to temp, the print starts. According to the on-screen countdown, this job was going to take 11 hours, and spoiler alert, long print times are definitely a recurring theme with this machine. During the print, the scraper arm makes a single pass between every layer. It keeps the resin mixed and the temperature even throughout the print. Again, it works well, but it's another reason this machine needs to be set up well and perfectly level, especially with larger volume parts. About 10 hours later, the print was finished, and that's when I realized I forgot to scale it up. I meant to print this thing at 200%, so 26 hours later, again, I had the statue I really intended. It came out perfect. Seriously, every part fit together straight off the printer. All I needed was a little sanding on the support interface points. No filler, no heavy post-processing. The surface finish is incredibly smooth. I left anti-aliasing at the default setting and didn't enable fuzzing. And even so, I couldn't find any noticeable layer lines or voxel stepping. The subtle fabric texture came through beautifully, and the fine hair detail looked sharp and clean. At this size, I honestly don't think a higher resolution printer would have delivered anything noticeably better. In fact, this turned out better in one crucial way. No warping. Even on the flat or heavily supported parts, everything stayed dimensionally true, which is why I was able to just friction fit this entire statue together. It was the same story for the smaller version of the model, which in hindsight didn't really need to be split into multiple pieces. For the cape, I switched to PAF10, HeyGears flexible modeling resin. A part this thin printed in a typical modeling resin would have been brittle and prone to snapping, but with this material, I can drop it on the concrete floor and it won't break. Superman's not losing his cape today. Again, using the PAP 10 resin, I loaded up two of my go-to test miniatures, my 32mm scale Mahogany and 75mm scale Artemis models from DM Stash. The print consisted of 3,779 30-micron layers and took 16 hours and 15 minutes to complete. And once again, the final results were solid. At this scale, I did notice that the surface detail isn't quite as crisp as what you'd get from the Reflex RS or from other high-resolution printers, but after a coat of high-quality primer, the difference is really only visible under magnification. Once painted, I don't even think the most discerning tabletop gamer would really ever notice. Where the Reflex 2 really shines again is in precision. On the Artemis model, the way I orient and support it, the lower body and cloak print as two separate points that join just below the shoulders. On every other print I've used this file, there's always been a subtle misalignment, slight layer shifting right where those two parts meet. But on the Reflex 2, the join was perfect. Clean seam, no shift, no warping. That level of dimensional consistency might not matter much when you're making minis for your next D&D session, but it does matter for functional components, assembly tolerances, and tooling validation. And that's exactly what I'm diving into next. But if you're looking for a deeper breakdown on how this printer performs specifically with miniatures, I highly recommend checking out Ross's review, aka Faux Hammer. He's the expert when it comes to minis and the hobbyist user experience, and he's also done a full deep dive on the Reflex 2, and now we get to what this printer is actually intended for. I swapped in the PRM vat, connected the pulsing release module 2.0, and inserted a bottle of HeyGears PAU20 tooling resin, a polycarbonate-like material designed for tooling validation and small batch production. To test how precise this system really is for tooling validation, I printed my Ultralight mouse body. Now, full transparency, this isn't my original design. I picked it up on Etsy a while back, but it's become my go-to standardized model for testing dimensional accuracy, precision, and assembly tolerances. So it was the perfect benchmark for this test. If you're unfamiliar with the term tooling validation, it's essentially the final step in a digital design workflow before you commit to manufacturing. You're making sure your CAD model is perfectly within spec, every tolerance dialed in, before spending thousands or even tens of thousands of dollars to have molds CNC'd, especially for something like injection molding. That's exactly the kind of scenario this model fits into. It's a retrofit shell designed to house components and electronics from a Logitech G305. If I wanted to mass produce this design, I need to be absolutely sure that everything fits precisely before sending the design out for tooling. Now, to be fair, a situation like this doesn't always require physical validation. When I worked as an electronics engineer, I was often part of a full product design team. The mechanical designer would already have my exact CAD files for the electronics, and everything could be worked out digitally. But in real world workflows, iterations still matter. Whether you're roughing out a new design, dialing in ergonomics, or testing physical interaction, it's common to print and revise. Speed matters in that process, and that's where the Reflex 2 struggles. This mouse shell printed at 50 microns consisted of 2,607 layers. Total print time was 16 hours and 6 minutes.
For context, the Formlabs Form 4, using the exact same file orientation and layer height, finished the job in just 4 hours and 23 minutes. That's almost 1/4 of the time, and that's with a basic production resin. Formlabs has a rapid prototyping resin that can do it in less than half that time.
Now, despite the slow print, the quality was fantastic. Holes were round, posts were clean, and across all 35 measurements I take between the two parts, the dimensional tolerance was within 100 microns. That's well within spec for tooling validation, and only about 0.2% less accurate than the same part printed on the Form 4. And keep in mind, this is a super thin walled model, and the PAU20 material was durable enough to handle handling and stress testing. So yes, it's absolutely capable of producing high precision prototypes that can stand up to functional testing or even limited production runs. But again, the print speed is a problem. 16 hours for a single iteration is more than 2 full working shifts. If I'm running a studio, I'm not paying a designer to wait around all day just to find out if a part fits. Not when there are machines on the market that can knock out the same job up to 4 times in a single shift. Because at the end of the day, when you're running a business, time is money. To further demonstrate how this printer handles real-world design work, I took on a full product development challenge. I wanted to spend my main fixed studio camera rig from the ceiling using a pivoting pole that could swing up and out of the way when not in use, and then drop down camera ready in just a few seconds. The core of the design is a custom bracket that connects my Magnus floating tripod head to a vertical pole, so I jumped into CAD and started designing it from scratch.
Long story short, even starting with simple shapes to verify fitment would take way too long on the Reflex 2, so I did all the iterations on an FDM printer. Once the final design was complete, I printed the final part on the Reflex 2 in the PAU20.
That part, consisting of 2,124 layers at 50 microns, took 21 hours and 12 minutes to complete. I also printed the same model in the exact same orientation on the Formlabs 4.4. That one came out slightly taller at 2155 layers, but it finished in 7 hours and 56 minutes. And that included an hour-long pause because I forgot to open the resin bottle, the printer detected the slow resin flow and the mostly empty vat and paused the print automatically and picked up right where it left off when I corrected the problem. You can actually see the pause line on the finished part. That's the kind of intelligent failsafe you expect from a high-end studio printer. But here's where it gets interesting. Aside from speed, the Reflex 2 absolutely held its own. The surface quality was flawless, no warping, no artifacts, no print defects of any kind, and the dimensional accuracy is shockingly good. To push both printers, I intentionally designed the bolt holes with an unrealistically tight tolerance, exactly 7.85 millimeters, which is just 50 microns larger than the bolt shaft itself. On the Reflex 2, the finished hole measured 7.8 millimeters, meaning it was off by just 50 microns. On the Form 4 version, the hole came out at 7.76 millimeters or 90 microns undersized. That's still well within Formlab's rated 150 micron accuracy for this part size, but it meant the bolt fit perfectly on the Reflex 2 and didn't fit at all on the Form 4 print without post-processing. As far as I'm concerned, that's a win for the Reflex 2. The tripod head dropped in and locked up flawlessly, and the durability of the PAU-20 part is crazy. I stood on the part with my entire body weight and it held without flinching. And I'm not going to say how much that is because I don't need to get roasted by my battle buddies, but let's just say this mount is way over-engineered. So bottom line, the precision and structural quality from the Reflex 2 is incredible. It produces a CAD-perfect functional production-grade part right on par with the Form 4, but again, speed is the issue. At over 21 hours, I couldn't afford to iterate this part on the Reflex 2. If I tried to do my entire prototyping process on this printer, it would have taken me days. Well, that's fine if you're just making a final part, but for rapid iterative design, it's a serious bottleneck. Just these small clamps took almost 8 hours to print. So yeah, slow speeds are still a deal breaker for me in many workflows, but when it comes to precision and the printing capabilities of the Reflex 2 paired with HeyGears materials, it's hard not to be impressed. Though the material lineup is still fairly limited. I tested out their PAT-10, which is their transparent resin, and while the prints were again slightly less detailed than when you'd get from a higher resolution printer, they were flawless in terms of execution. The base of the character model came out perfectly flat, no visible layer lines, and the material stayed crystal clear with zero yellowing. It's also surprisingly durable. Unlike typical cheap transparent resins that tend to be very brittle, this stuff feels more like ABS, tough with just the right amount of flex. And once again, the precision of this Reflex 2 blew me away. I printed this intricate antenna lamp model, a piece that usually fails on most printers due to compression and peeling forces, but the Reflex 2 handled it perfectly. And then I ruined it during post-curing. I used the performance cure mode, which adds heat and melted the delicate lamp filaments. Totally on me, but a good reminder that thin-walled parts might need gentler, rapid post-process setting, which doesn't include the bake function. This also highlighted one of the big limitations with the Reflex 2's build plate design. I wanted to print an optical lens grid array and a diffuser, both of which need to be printed directly on the build plate, perfectly flat and parallel with no supports, but the Reflex 2's perforated plate prevents that. The holes are great for improving flow dynamics during printing, but they completely eliminate the option of printing delicate flat parts unsupported. That's a problem for anyone doing engineer or optics focused work. An engineering grade printer needs to be able to print flat on the plate, no exceptions. I also tested PAE-10, which is HeyGears elastic resin, and it genuinely surprised me. I expected something closer to TPU, maybe a little rubbery, but mostly stiff. What I got was actual elasticity, like true elastomer behavior. It was perfect for something like this CV joint boot or these tiny actuator boots I printed. Both came out clean, accurate, and stretchy and functional. That opens up a huge range of possibilities, from medical and scientific use cases to something like classic car restoration. Credit for that last idea goes to James, aka Rising Ape. He's also done a review of the Reflex 2, although I don't think his experience was quite as smooth. All right, this is officially the longest video I've ever made. I'm losing my voice, and it's starting to feel more like a full-on Netflix train wreck documentary than a YouTube review. But I felt it was important to be thorough, because if you're considering dropping this kind of money on a 3D printer, you deserve all the details. And unfortunately, there were just as many negative issues to cover as there were impressive results to highlight. Despite producing prints that in many cases rivaled those from the $3,500 Formlabs Form 4, my experience with the Reflex 2 left me frustrated. The potential is absolutely there, but the execution just isn't. HeyGears has made some interesting design choices, but too many of them come with trade-offs that undermine the user experience. And the proposed fixes, I don't think they'll solve the real problems. They're working on speeding up printing profiles, but there's only so fast that scraper arm can move before it starts splashing resin everywhere. They floated the idea of disabling the arm movement between layers, but that's likely to cause uneven heating in cooler environments, especially for engineering resins that require consistent temperature. And maybe most disappointing, some of the key missing features, resin feed control, vat level monitoring, active ventilation, are available, but only on the $3,000 Reflex 2 Pro, which apparently HeyGears is also releasing today. Maybe. So again, who is this printer actually for? If I ran a design studio, I wouldn't buy this machine. The lost productivity from the painfully slow print speeds alone would kill the ROI, and that's before we even talk about cleanup. Draining and cleaning out the vat, especially after running thick, viscous engineering resins, is a huge time sink. No employer wants to pay their engineers and designers to scrape goop out of a tank. Even the interns have better things to do. For businesses and even solo makers or entrepreneurs focused on product development or small batch production, I'd honestly just spend the extra $1,000 and get something like the Form 4. It's not perfect either, but it was purpose-built for design, engineering, scientific, and medical workflows. The speed, user experience, and responsive customer support make it a far better tool for anyone who needs to rely on 3D printing professionally. That said, I started this video, what feels like days ago, by saying there's one very specific type of user who might still benefit from the Reflex 2, and I stand by that. If you want this level of print accuracy and durability at the lowest possible cost, and you truly don't care how long it takes to get there, the Reflex 2 delivers. For that very narrow use case, it's arguably the best printer available. But for anyone else, at least at this point in time, I can't recommend the Reflex 2, which is disappointing because I still think the Reflex RS is one of the best all-around MSLA printers out there. And honestly, the core hardware inside the Reflex 2, the light engine and display system, is only outclassed by machines that cost significantly more. So it's not the tech that's holding it back, it's the overall user experience and the fact that basic features you expect at this price point are locked behind the Reflex 2 Pro, and honestly, that feels a little sleazy. I'll keep the Reflex 2 up and running here in the makerspace, and I'll revisit it down the road to see if HeyGears manages to fix what's broken, but I'm not entirely hopeful they can do that without making some actual hardware changes like a deeper splash-resistant vat, a more controlled resin feed system, and a scraper arm that can move faster without making a mess. Until then, it feels like they've engineered a precision machine that's being held back by its own design choices.